Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off in our previous lesson, the lesson on functions. Okay, in our previous lesson, we looked at the definition of functions. We were able to distinguish functions from non-functions using the definition. Okay, and we learned the notations of functions. And we ended at evaluating functions. So we are going to continue from evaluation of functions. Okay, so we did only one worked example under that. Now we are going to look at, okay, the second worked example. So this is going to be lesson 2 of what functions and core math function to be specific. Okay, so second worked example, what are we supposed to do? You've been given this function. Okay, it is not that pretty. You can see that the previous functions that we worked with, that we evaluated, okay, we had only, okay, a numerator function, meaning only a polynomial function. But this time around, we have a rational function. Okay, don't get it twisted. You know rational numbers, is that not it? Okay, what is a rational number? Assuming this is the only question your semester exam, this is the only question there. You've all done real number system. So what is a rational number? My professors, oh, you think the question is trivial. That's why you don't want to answer. I'm waiting. What is a rational number?
A rational number is a number that can be expressed as a fraction of two integers, maybe having a numerator and a denominator.
That's all. Not bad anyway. Okay, but it falls short of something. Okay, any other? Okay, simply we'll say that a rational number is any number that can be expressed in the form A, oops, let me go back. In the form A over B, but with the condition B not be equal to 0. You remember?
Yes, please.
Okay, so it's the same thing. Here, okay, anytime you have an expression over another expression, okay, because we call this a rational number because we know that A will be a number, B also will be a number. Okay, so you have a numerator number, a denominator number, so we call it rational number. However, if you have an expression over another expression, it becomes rational what? If a number over a number is a rational number, then expression over an expression is rational what?
Number.
No. If a number over another number is referred to as, okay, where the denominator is not equal to 0, it's referred to as a rational number. Okay, then an expression over another expression will be referred to as. Oh, you should get a
rational
connection.
expression.
Rational expression. So rational numbers because you are dealing with numbers. Okay, rational expression because you are dealing with expression. You get the point. Okay, however,
Yes.
remember in our previous meeting, I said, okay, functions are expressions with special names. Is that not it?
Yes, please.
So it means the numerator here, if it's an expression, then I can say that this is also a function. The denominator here, if it's an expression, I can refer to that as what? As a function. So indirectly, this is what I'm trying to say. I can say that my h of x will be equal to a function f of x over another function j of x, where f of x is this 2s minus 1, then j of x is s plus 1. So if I have a number over another number to be a rational number, an expression over an expression to be a rational expression, a function over a function will give us
a rational function.
A rational function, as simple as that. So I can call this rational expression or rational function. is the same. But you can see that this condition is very critical, just as the condition here is very critical. So here is the same thing. Your B now is the x plus 1. So indirectly, you have x plus 1, okay, not equal to 0, but you solve for x. So it means x should not be equal to -1. You move this one, yeah, okay, here, just like you are solving an equation. And that is what we attach. And you can see that if s is equal to -1, you get -1 plus what? 1, which will give you 0, and the denominator will be 0, making the rational expression and therefore the rational function here, okay, undetermined or undefined. Is that clear?
Yes, please.
Okay, so here, that was just by the way. So we are going to work on, okay, or we are going to evaluate rational expressions, rational functions for that matter. So quickly, let's see the same thing. We said anytime you are evaluating, what do? You substitute, then we simplify, as simple as that. Okay, so that's all that we are going to do here as well. Only that the function is a rational function. So as usual, when you read question, check whether you have salient part to underline. You don't have any salient part to underline. After that, the first thing that you write is solution. If the question is numbered, your solution must be numbered appropriately as well. So in this case, 2. Okay, the information that I need here is the function. So I'm going to extract the function. Okay, so given, and what's the name of my function? Thankfully, the function came in the equation form, or the relation form, I should say. Okay, so you equally extract it in that form. So I'll get 2x minus 1 all over my x, okay, plus 1. But that's not all. Okay, x not equal to -1. So this one is just copy and paste. You just extracted, then now you come to A. So A, what are we supposed to evaluate? Evaluate h of what? 1. So it means wherever you see x in h of x, it is now 1. And you can see that x appears in the numerator and the denominator of what? Your h of x. So in this case, I'm going to get 2. I'm substituting for x. My new x is 1. Then -1 all over. Okay, I'm substituting for s. Remember, okay, my new s is 1. I put it in brackets. Remember that advice I gave you. Anytime you are carrying out your substitution, always put it in brackets for safety reasons. Okay, so in this case, I go and remove the bracket. This will give me 2 times 1, which is 2. Then -1 for the numerator. The denominator will give me 1 plus what? 1. So I'm going to get numerator 2 minus 1, which is 1. Then over 1 plus 1, which is the denominator 2. So now you are done. Therefore, okay, h of what? 1 is equal to 1 over 2. And we could have concluded here as well. Is my point well made?
Yes, please.
Yes, please.
Okay, wonderful. Okay, so we have 2 more to do together. Then the D will be yours. Okay, so let's go. Okay, B. Okay, what are we supposed to find? H of what? -3. Okay, so we know this will be equal to, okay, my numerator, wherever I see x, okay, it will be -3. Denominator, wherever I see s, equally -3. So I'm going to get 2 into -3, okay, -1 all over -3, okay, then plus 1. Okay, so I'm going to write this will be equal to, okay, my numerator, I expand the first, okay, term. So that will give me -6. Okay, then -1 all over my denominator will give me -3 plus 1. I hope you are following.
Yes, please.
Great. So this then gives us what? -7 over what?
-2.
Over -2. So you know that this negative and this negative will cancel. So in effect, we are going to get 7 over 2. Is that clear?
Yes, please.
Okay,
Yes,
however, I'm going to draw my conclusion. If I do something wrong, you tell me. Otherwise, we'll continue. So we have, therefore, h of what? -3 is equal to 7 on 2. Am I right?
Yes, please.
Okay. Who said yes? Janice or Sayram? Sayram. Okay, Janice. Am I right?
No, please.
Okay, what is wrong?
It's a improper fraction.
So,
Supposed to be in a mixed fraction form.
perfect. Akusika, you get it? And remember, I
Yes.
told you, you don't conclude with which type of fraction unless otherwise stated. An improper fraction, unless otherwise stated. Okay, so now we go and do the right thing. So that will give us, if you change, this will give us 3 whole number, 1 out of what? Out of 2. So this is supposed to be where you are supposed to end. Is my point well made?
Yes, please.
Okay,
Yes.
great. So we are going to look at C. You can see that the C, okay, your value that you are evaluating your function at is not that pretty. It's a fraction. But don't worry, okay, you've done order of operations, so you should be able to deal with it. So I'm going to move to the next, okay, page, then we'll do the C. C, okay, what are we giving? We've been giving h of half, h of 1 over 2. So this means wherever we see h of x, wherever we see x in h of x, it is what? 1 over 2. So that will give us 2 times 1 over 2. Okay, then minus 1. That's my numerator. All over, okay, 1 over 2. Okay, I'm putting it in bracket just for the simple advice that I gave you. So plus 1. So this in effect will give us, remember, anytime you are multiplying, okay, and you have a numerator and a denominator, okay, check whether you can reduce before you multiply. Take note. And here you can see that we can reduce, we can cancel. Okay, 2 will cancel this 2, so you'll be left with 1. So it'll be 1 times 1. And the numerator, the first term there now becomes 1 minus 1 all over your denominator, which is what? Half, okay, plus 1. Is that clear?
Yes, please.
Yes. Please.
Okay, so this in effect is going to give you numerator becomes 0. Denominator will be 1 plus half will give us 1.5, which is the same as 3 on 2. Am I right?
Yes, please.
However,
Yes,
we
please.
know 0 over any number is what? Zero over any number
0.
is 0. Any number over 0 is what?
Zero.
Okay, use your calculator and see if your calculator will give you 0. Okay, so here we know it's 0, so do the other one. Any number over 0 and see what will happen. If your calculator gives you a specific value, throw it away or check the expiry date.
It's an error. It's a math error.
It will give you math error, so it means it doesn't exist. Okay, it doesn't exist. So anytime we usually write undefined, you don't write math, okay, I mean math error. You write undefined, sometimes you write the infinity or you write undefined. So we'll talk more about that very soon. So at this point, what do we have? Therefore, h of what? Half, okay, is equal to what? 0. As simple as that. Afa.
Yes, please.
Okay, great. Okay, so the D obviously is in red, so it cannot be mine. So let's see. This is your first class assignment. So you do that one, then you submit. Is that clear?
Yes, please.
Okay, so try. Then after this, I know that we are indirectly, okay, somehow done with the evaluation, sort of. Then we go and look at the algebra. Okay, so now we are going to look at the solution to the class assignments. So as usual, this is what you are supposed to do. I'm addressing some of the concerns. Some of them are intentionally ignored in your, so take notes of them. Okay, so what do we have? We extract, so given, the question is not numbered. So we don't number our solution as well. So given h of x, and h of x we know is what? 2x minus 1 all over x plus 1. But don't forget to attach that condition. This one is just copy and paste. So you just extract exactly what is there. Don't leave this. It's part of this. Okay, so one concern addressed. Then after that, we are asked to evaluate this. So you have to come and write h of, don't write equal to. This is not a step. This is also cut and paste. So -2 on what? On 3. Okay, no equal to. It's now that you are going to work on it. So what we are asked to find will now be equal to. You go and substitute. So that will give us what? 2 times -2 on 3. Okay, -1 all over. Okay, -2 on 3 in brackets because of the advice. Other than that, the brackets would not even be necessary in this case, +1. Now, remember we said before you multiply, check if you can reduce. That's if you have a numerator and denominator. Here you can't reduce, so you have to multiply. So it will be 2 times -2, which will give you -4 all over 3, all over 3, then -1. The whole of this one over -2 on 3, then plus what? 1. Now, your numerator, if you look at it critically, per order of operation, so here you can even use your calculator straight away. But if you want to deal with it mentally, there's the advice. Okay, the numerator, the denominator has what? A long division bar separating. So once you have that, take note. At a point, this long division bar must change to the normal division symbol. And the only point that you can do that is when the numerator is expressed as a single fraction and the denominator equally as a single fraction. Other than that, you cannot change this one, this long, division bar here to the division symbol. So my next step, I want to do it manually, okay, or mentally, I should say. So in this case, I am going to work on the numerator. The numerator, if I'm writing it as a single fraction, I will take the LCM. The LCM will be 3. Okay, I ask myself, 3 goes into 3 how many times? It will be 3 times what? Sorry, it will be 1 times what? -4, and that will give us what? -4. Then minus, this is over 1. Okay, it's 1 over 1. 1 goes into 3 how many times? And that will be 3 times 1. So that will give you 3 here. The whole of, now this is a single fraction. So I can write divided by. I know that what will come here also will be a single fraction of what is here. So I can change. Okay, so I'm going to have my bar, my LCM will be 3. Okay, 3 again goes into 3 how many times? 1 times -2. So I'll get -2. Then plus, this is over 1. 1 will go into 3 how many times? 3 times 3. So I will get 3 here. So in effect, this will give us -7 over 3, okay, divided by, okay, 1 over 3, which you are going to get -7 on 3, then times 3 over 1. So now this can cancel that, and you get -7 over 1. So you draw your conclusion. Therefore, your h of -2 on 3 is equal to -7. All correct. Okay, and like I said, you can use your calculator and you move from here to here. Your calculator, if you use your calculator, then this is what you are going to get. Your calculator will give you -7 over 3 all over, then the denominator will give you 1 over 3. And take note, anytime you have a fraction this way, if I have A over B, all over maybe C over B, if my numerator fraction and the denominator fraction, they have the same denominator, they will cancel, and you'll be left with A over C. So that's how come this one gave you -7 over that. So it means this one, the 3 and the 3 here will cancel because they are the same. Then it will be left with the numerator. So it will be -7 over the numerator here 2 over 1, which will give you -7. Is my point well made? Hey, Serum is
Yes,
missing in
please.
action. Okay, it seems Serum is missing in action. I don't know whether it's the network. Maybe she will get back. Okay, so please take notes, okay, of the solution and all the concerns addressed. Okay, Serum is back, but her audio not connected yet. Okay, all right, Akushika, are you fine? Are you fine?
Yes, please. They turn off our lights, so the Wi-Fi will.
Okay, all right. I'm talking about the, you've seen where your problem, okay, was, right?
Yes, please.
Okay, so it is how you combine this. Okay, your numerator here was the problem. So I circled that. Okay, just to draw your attention to that. So that will be it for the evaluation. Now let's go and look at, okay, the algebra. Okay, so now we are going to look at algebra of what? Functions. Okay, remember functions are expressions. So once you have algebraic expressions, okay, indirectly will be algebra of expressions. Okay, then we are going to look at algebra of functions, the same thing. So when we match, whenever we talk of algebra, basically we are going to look at, or we are talking about addition, subtraction, multiplication, and division, that's all. So if I mention or I say algebra of function, then we are going to look at how to add functions, how to subtract functions, how to multiply functions, and how to divide functions, that's all. So algebra of functions deals with the addition, subtraction, multiplication, and division of what? Functions. As simple as that. So let's look at our first worked example. Okay, given that, okay, this function f, this function g, this function h, so three functions. Find f of x plus g of x. So you can see that, okay, you are adding two functions. Here you are subtracting. Here you are subtracting as well. Adding and subtracting, adding and subtracting. So let's deal with the first three. Then this one will be yours, okay, to deal with, okay, in the near future. So quickly, let's go and look at the solution. Okay, so question one, solution one as well. Okay, do we have any information that we can extract? Yes, the functions. Okay, so the function I write given f is such that x maps to 2x minus 3. Am I right?
Yes, please.
Really? So that's what you also write. Rebecca, you are welcome. What happened?
Thank you. Please, the network at my place is very bad.
It's very bad, eh? Okay, don't
Yes,
worry.
please.
Okay, it will be fine very soon. Okay, so you try and relate. Did you do functions in school?
No, please.
No, so but were you able to watch the video?
Please, because of the network, I wasn't able to watch it.
Oh, you couldn't open at all.
Yes, please.
Okay, so you try to relate what we are doing. I'll have you in mind whilst explaining, but you need to watch the first video and the solution as well so that you can relate.
Okay.
You know, math we build on. That's why
Yeah.
it's usually not advisable to miss classes. But fortunately for you, if you miss classes, you will get the video to watch.
Okay.
Okay, all right. So you do that to complement. Okay, so here, remember, we cannot do this. We said, okay, we avoid extracting functions in which form? Remember, we said we should always avoid extracting functions in the mapping form. So we shouldn't do this.
Yes, please.
Okay, so take notes. Okay, the temptation will be there for you to extract directly. I've told you that the mapping form, they are best seen in what questions, but not in your solution. So in this case, I am going to do the needful. So what do I have? I change all the mapping forms of the functions, okay, to their corresponding relation form. So it will be f of x is equal to 2x, okay, minus 3. Okay, then what else? Okay, g of x. Okay, so I know it won't go there, so I'm coming down. But if it will go there, please make sure you continue. So that will give me g of x to be equal to, what is g of x? S squared, okay, plus 4x, then minus 4. But that's not all. And my last function is what? H of x. So h of x will be equal to 2s squared, okay, minus x. So but I've extracted all my functions, remember. Then after that, you come to a. So now, because all these, you have it above a, so it means it's a general information that you are supposed to use to solve a up to what? E. So now, a, what are we giving? F of x, okay, plus g of x. So here, this is all that we are going to do. F of x is an expression you know. G of x is also an expression you know. So you just come and substitute. So I'm going to write this an expression. I start introducing my steps with implication. Am I right?
Yes, please.
Sure.
Yes.
No. Expressions, steps are introduced with equal to, not implication, remember.
Yes, please.
Okay, so you were caught in the web. Okay, so don't fall victim to my tricks. All right, okay, so anytime I ask such questions, think through, probe it further before you answer. Is that clear?
Yes, please.
Okay, so now this is what we have. Remember, we need to get a substitution for f of x. We know the function f of x. Okay, we know this. So we are going to get a substitution for it. And this substitution is 2x minus 3. And remember the advice. Okay, anytime you are carrying out substitution, whatever that you have, put it in brackets. So I'm substituting 2x plus 3. Sorry, 2x minus 3. I put it in bracket, then plus, though the bracket is not necessary, but I've told you in certain situations, the bracket will be necessary, and you ignoring it will be costly. So you are just playing it safe. Okay, whether it is necessary or not, I'll write it. You get it? So that I'm playing it safe. So g of s, what's a g of s? G of s, you know, is what we have here. So you also put that one in brackets. So x squared plus 4x, okay, minus 3. Oh, sorry, minus 4, forgive me. Okay, then now you come and remove the bracket. This is times 1, so it will give you 2x minus 3. Then plus, this is 1 times the whole of this, which also give you s squared plus 4x. Okay, then minus 4. Okay, let me clear that and write it well. You should always avoid deepening. Okay. If possible, cancel it and write it again. So at this point, after your expansion, the removal of the brackets, that is expansion. Okay, you check if you have like terms to combine. And okay, whenever you are arranging terms, okay, in algebraic expression, okay, you arrange them in descending powers of x. So it means you have to look for the x with the highest power, followed by the next power, okay, higher than in that order. So here, the x with the highest power is s squared, but that is the only term. I have only one term in s squared, so I can't combine it with anything. It's positive. I will start with it. Then I go to my next term. From s squared, I have to go to s to the power 1, which is the linear terms. I have 2 of them, 2x, then 4s. So 2s plus 4s will give us plus 6x. Am I right?
Yes, please.
Then you have the constants, minus 3, minus 4, that will give us minus 7. Okay, so you come and draw your conclusion. But when you mature, you could have drawn your conclusion here. You can draw your conclusion here. So we have, therefore, f of x plus what? The g of x, whatever you were asked to find, is equal to x squared plus what? 6x, okay, minus 7. It is none of your business to factorize this. You don't factorize. Even if it's factorable, you don't factorize. Take notes. You leave it this way. Factorization becomes necessary when there is a denominator, okay, other than a constant. Take notes. All right, so any questions? Can I move on to B? Are we all fine?
Yes, please.
Okay, good. All right. So I'm moving on to Esther. I'm sorry, Rebecca. Are you able to relate? Have you been able to pick
Yes,
something? Okay, good.
yes.
All right. Okay, great. So now remember, when you are moving from one sub question to another sub question, okay, that's where you leave a line or 2 maximum. But it will better we leave just a line now because of constraints. And I said I will send the constraint paper to you for you to know. So it means every step on the way, I introduce it with equal to because I'm dealing with expression. And as I write, I always write close to the margin. and I don't leave any space between my steps. So all lines must be occupied. Okay, so now B, what are we giving? G of X minus what? F of X. So this is an expression. We start our steps with equal to. G of X, we know that is what? S squared. Remember, we put it in brackets. S squared, okay, my plus 4x, then minus 4. That is your G of X. Then minus F of X, you are also, okay, going to substitute. So you put whatever that we are going to substitute in brackets, which will be 2x minus 3. Okay, so you can see that that's the more reason why I said whether necessary or not, just put it in brackets. You can, if you ignore the brackets here, you are doomed. Because the what you have there is negative. If it's plus and you ignore the brackets, it will not be costly. So that's why I said always put it in brackets, always, whenever you are substituting. Okay, so at this point, you come and remove the bracket. So the first bracket, when you are removing the coefficient here, oh, sorry, the factor here is 1. So multiplying each of them, so you get s squared, okay, plus 4x. So 1 times any quantity is the quantity itself. Okay, then minus 4. Then this will give you minus 2x. Then this time, this will give you plus 3. Do you agree?
Yes.
Okay, very good. So now remember, after expansion, that is removal of brackets, you combine like terms and rearrange if possible, if necessary. So in this case, I am going to draw my conclusion at that point where I will combine like terms and rearrange are matured. So it will be therefore my G of X minus what? F of X will be equal to, I'm combining only one term in S squared. Okay, I have 2 terms in X, so 4x minus 2x, that will give me plus 2x. Okay, I have 2 constant terms, minus 4 plus 3 minus 1. I'm done. Is my point well made?
Yes, please.
Very good. You are doing well. Keep it up. Okay, so now we are going to look at that of the C and the D. So you can see that as we move on, the questions become a little, okay, complicated, but no issues. You are smart. You should be able to deal with it. Okay, so let's go and look at that of the C. Okay, so C. Okay, what are we giving? F of X. Okay, minus 3 times h of x. Okay, so there's an expression. So this will be equal to, we are going to substitute f of x and h of x. So f of x, we are substituting, we'll put it in brackets. So what is f of x? And that is 2x, okay, minus 3. Minus 3 into h of x. What is h of x? H of x, we know, is what? 2s squared, okay, minus x. Is my point well made?
Yes, please.
Okay, great. So at this point, what do? We go and remove brackets and combine like terms, if any. So here, if you are removing the bracket, it will be 1 times odd. So that will give you 2x minus 3. Then this will give you minus 3 multiplying that. So you get minus 6s squared. Okay, then plus what? 3x. All correct?
Yes.
Okay, so here, we know we need to, after removal of brackets, okay, we need to combine like terms, if any. And we obviously can see like terms. Okay, at least we can see the x terms being alike. Okay, Janice. Prof. Janice, are you there?
Yes, please. Sir, you see where the 3 is? I was asking, can there be a situation where there will be a fraction?
A fraction where? This 3.
Yes.
Yeah, it can be a fraction. This constant here can be any number. It can be a fraction. You just have to remove the brackets. Okay, it's the same thing. If you move the brackets, you will have what? A fraction. And anytime you're in algebraic expression, anytime you have an algebraic expression and you see at least one of the terms involving a fraction, take the LCM and write it as a single fraction. but don't multiply through by the LCM because it's an expression. Okay, for expressions, you avoid multiplying through or dividing through by a constant, okay, or even a variable. If you do that, you change the expression altogether. However, if you are dealing with an equation, an inequality, you are allowed to multiply through by a constant, but not a variable. Okay, the reason why I'm saying this is that, okay, assuming I have 2x plus 2, okay, there's an expression. If I divide by 2, I will get s plus 1. Is the expression 2s plus 2 the same as s plus 1? Think through.
No.
No. So you can see that by reducing it or by dividing through by 2, you have changed the expression. So you are not working with the original expression. You are working with a different expression altogether. So even this one, again, if you multiply by 2, you get this. These two are not the same expressions. So take note. However, if you were solving an equation, let's say 2x plus 2 is equal to 0. Because, okay, there's an equation, it is allowed to divide through by a common, okay, constant, okay, or a common numerical factor. So in this case, we are going to divide, and that will give us x plus 1 is equal to 0. If you solve, you get s to be equal to minus 1. If you don't divide through straight away and you go and solve your usual way, you get 2s is equal to minus 2. You write it again and you divide, you end up getting s to be equal to minus 1. Is that not it? So whether you divide through or you don't divide through initially, you will end up getting the same result. That's if you are dealing with an equation. For equations, inequalities, you can only divide and multiply by a constant. For expressions, you cannot divide or multiply by a constant or a variable. Take notes. Is my point well made?
Yes, please.
Yes,
Okay,
please.
so when you have fraction, if immediately you solve your solve, so let's say I have 2s squared, okay, plus 1 over 3x, okay, then plus maybe 4x minus 2. And I'm asked to simplify this. Because this is an expression, okay, I will take the LCM and simplify the numerators. Or the numerator. Is the numerator that will give you a like term. Because your denominator, LCM, will only be a term. So in that case, if there are any terms to combine, it will come from your numerator. Then you work it out. I guess my point is well made now.
Yes, please.
Great. Okay, so now I am going to clear this, okay, to give room for, okay, my conclusion. Okay, so here, remember, we are going to conclude. But before we conclude, I'm going to say something, or I'll write, okay, this. What do we do? You know, ordinarily, if you are arranging, we said you arrange in decreasing powers of x. So it means the highest power of s, yes, minus is s squared. Okay, so this is the highest power is what, 2. So it's this term that you write first, followed by your linear term, which will be 2x plus this. So that will give us plus 5x. And then minus 3. Do you agree? Hello, do you agree? Are you with me?
Yes,
Yes.
please.
Okay, very good. Now, this is my humble advice. In algebraic expression, okay, you avoid concluding with an expression that contains, okay, a negative as the first term. Unless, okay, in that expression, all the terms are negative. But immediately you see one positive term in that expression, start with that positive term. Though usually you are asked to arrange in descending powers of x, but in algebraic expression, you avoid, okay, starting your term with a negative one. Your expression with a negative term. So it means in my conclusion, I will rearrange. So therefore, I will have f of x, okay, minus 3h of x will be equal to, I can see I have a positive term here, which is the 5x. I'll write that one first. And the other two negative terms, you can follow it up. So I'm going to write 6s squared, then minus 3. All correct?
Yes.
please.
Yes,
Okay.
please.
So as you mature, you can do what I did here. You can draw your conclusion here. So when you are combining, you know, okay, I'm supposed to start with s squared term, but it's negative. So I will shelve it. Then move on to the next term. You're supposed to be the s term. Okay, that is positive. So I'll write that one first. Then I'll now come and write what I shelved, followed by the other one. You get it now?
Yes.
Yes, please.
Okay, great. So we are left with what? Okay, the C to, okay, look at. Okay, so quickly, let's go and look at what? Oh no, we've done the C. So it's the D that is left. Okay, the D. So we are going to do that together. However, let me see whether you can try. So try the D and submit. Okay, let me see how you will deal with it. So try it and submit. So let me pause. Okay, so the D here, you know, okay, you write exactly what you have there. You come and carry out your substitution. You remove the brackets, but don't forget the +2. So it is 2 into h of s you substitute minus 3 into g of s you substitute, then +2. You remove the bracket, combine like terms and rearrange if necessary. So this is what you were supposed to get. Okay, all right. So thank you very much. Now we are still on the algebra, only that this time round, we've done addition and subtraction. We are going to look at multiplication. Okay, so take notes. Okay, so quickly, let's go and have a look at our second question. So you can see that in our second question, we are looking at multiplication of products or functions. So same way, let's go and look at what's the solution. Okay, so this is it. Questions are numbered. When you read questions, underline the salient part, if any. Here, we don't have any salient part. So what do? We straight away go and write solution. Then we write what the major question number. And any information that you need to extract that will help you find whatever that you are asked to find. That's what you are asked to find. Extract that information. So here, we've been given function. The function, again, the functions came in the mapping form, but you extract in the relation form. So I will have f of x is equal to, okay, s squared plus 3x. Okay, then, comma, my g of x is equal to what? S squared minus 1. Okay, that's not all. And, okay, my last function, h of x, is equal to what? X squared plus 4x, okay, plus 3. Okay, so now you come to A. Okay, you don't leave any line unattended to. So A, you are looking for f of x times what? J of x. So again, you go and substitute your f of x. Remember, as you move from one line to the next line, you write close to the margin. So f of x, you are substituting, you put it in brackets. So that will give you x squared plus 3x. Times, you are substituting j of x, you also put that in brackets, and that is x squared minus 1. Is my point well made?
Yes.
So failure to put,
Yes.
okay, both of them in brackets, even one of them in brackets, okay? So if you put only one of them in brackets, you are doomed because your functions are more than a term function, more than a monomial function. So anytime you are substituting, make sure you put it in brackets. So you know the rule. So at this point, it's just like the whole of this multiplying the whole of this. And in JHS, I know you come and write s squared multiplying this, but please, I'm only writing it. Now you are matured. Okay, so you will distribute straight away. So it will be x squared multiplying this, then plus 3x also multiplying your second factor, s squared minus 1. Am I right?
Yes.
So JHS, this is how you were. So Here, this step is not very necessary. You can always ignore this step and come and do this. This will multiply this, and that will give us s to the power 4. Am I right?
Yes, please.
Then the s squared will multiply the 1. So the first term of the first factor will multiply all the terms in the second factor. Same for the second term of the first factor, multiplying all the terms in the second factor. So I will get s squared times minus 1. So that will give me minus s squared. Then 3x times s squared, and that will give us, help me.
3x.
3x what? X 3x times s squared, s cubed. Okay, s to the power 3. Okay, so then minus 3x times 1 will give you, 3x. So now you've expanded. You check if there are any like terms to combine. Do you have any like terms to combine?
No, please.
No. So we can draw our conclusion. So Rebecca, conclusion is very important. So we are going to write therefore your f of x, whatever you were asked to find, times the g of x is equal to, so here I am going to rearrange in descending powers of x. So I will bring the cube term next. So it's plus 3s cubed, followed by the square term, and that is s squared, followed by the constant term minus 3x. Okay. That doesn't mean if you write it this way, exactly the same as this, will mark you down. No. Okay, it's the same expression, irrespective of the arrangement. It's the same expression. Is that clear?
Yes.
Yes.
Okay, very good. So that will be it for the A. Now let's go and look at that of the B. So B, so when you are moving from A to B, you leave a line, okay, or two, but I've told you one will do. Okay, so B, what are we giving? J of x. And dot, the dot here is what? The dot product. So remember, there is a difference between this dot. If you have, let's say, 2.3, this is read as 2.3. Is that clear?
Yes, please.
Okay, now let's see this. What's difference, okay, do you see between these two?
Please, in the first one,
Mm-hmm.
the dot is down.
It's down. Very good.
And then the second one is in the middle.
It's in the middle. Very good. So when you have your dots to be in the middle, okay, it ceases to be the decimal dot. It becomes the product dot. Is that clear? So you know how to place or position your dots to carry a certain meaning. So here I have g of s dot. My dots will not come down. It will be in between, and the other function is what? F of x. Okay, even if it is down, you cannot get a decimal involving what do you call it? Expressions. Decimal will be for values, not, okay, variables. Is my point well made?
Yes, please.
Okay, so at this point, we know this is the same as, okay, g of x multiplying f of x. So this dot, that is the meaning. So anytime you see this dot, now you know the meaning. Don't get confused. So g of x, we know what is g of x. That is s squared minus 1. So in brackets, s squared minus 1. Remember, I'm substituting. Then dots, okay, your f of x. What is your f of x? F of x is what? Your x squared, okay, then plus 3x. Okay, so at this point, you know how to do this. So this time around, I'm going to deal with it the matured way. I'm going to skip this step. Okay, so I know this will multiply all the terms here. So I'll get s squared times s squared. That will give me s to the power 4. S squared times 3s, and that will give us what? Plus 3s cubed. I hope you are following my professors.
Yes, please.
Yes, please.
Great. Then you come and you are done with the first term of the first factor, multiplying all the terms in the second factor. Then you come to the second term of the first factor, multiplying all the. So minus 1 times s squared will give us minus s squared. Minus 1 times 3x will give us what? Minus 3x. So at this point, you've expanded. You ask yourself, do you have like terms to combine?
No, please.
No like terms. So again, you draw your conclusion. Therefore, j of x dot, okay, f of x is equal to, here it is already arranged in the form that you want in descending powers of x. So x to the power 4 plus 3x cubed, okay, minus x squared, then minus 3x. All correct?
Yes, please.
Okay, so we have 2 more to go. I will do the C with you, then you do the D. Okay, then you submit for me to know whether you understood, okay, that of the C, or you have understood what we've done so far. So let me go and clear what is there. But at this point, any questions? Wow.
No, please.
Okay, so we are fine. We are following. Great. We thank God. So the last one that we are going to do together, which is the C. Okay, what are we giving? We've been given 2f of x, then times what? H of x. I can even remove the times there. The meaning will be the same. Or instead of the times, I can put dots there. Is the same. So here, this will be 2. You substitute your f of x. And f of x you extracted is here. And that is s squared plus 3x. So s squared plus 3x. Then times your h of x, you are also going to substitute. Remember, you put it in brackets. And that is your s squared, okay, plus 4x, then plus 3. Okay, so at this point, this is what you need to do. Okay, you know, anytime you have more than, okay, 2 factors, and you are going to multiply, here you have 3 factors. 2 here is a factor of what you have here. S squared plus 3x is a factor. Then s squared plus 4s plus 3 is also another factor. Okay, so this is a monomial factor, a binomial factor, and a trinomial factor. Am I clear?
Yes, please.
However, whenever you have more than 2 factors and you are going to multiply, this is the clue, or this is the hint, so this is the information. Okay, anytime you are multiplying, okay, first of all, multiply the factors with the least number of terms, irrespective of their position. Multiply those 2 factors, the factors with the least number of terms. So this factor is a monomial factor, a 1-term factor. This is a 2-term, like I said, a 3-term. So the factors with the least factors, okay, I should say the factors with the least terms, okay, will be this monomial factor and this binomial factor. Is that clear?
Yes, please.
Okay, so it means we are going to multiply, or it is convenient for us to multiply these 2. So I am going to have, okay, take notes. So if I'm multiplying this, I'm not removing the bracket entirely because there is another, okay, factor here. So I'm pushing this one in. So that will give me 2x squared. Okay, then I will get what? Plus what? 6x. Is my point well made?
Yes, please.
Now I can ignore the times and write this way. There is nothing wrong with it. If you write the times too, okay, there is nothing wrong with it. Only that we need to show maturity in our presentation. So this will be equal to, now you can see that you only have 2 terms, 2 factors. So that one, you don't ask yourself, these factors, because you have to multiply these 2 factors automatically. So my first factor, all the terms, the first term, multiply all the terms here. So 2s squared times s squared. That will give us 4s to the power 4. Am I right? My professors, are you there? Am I right?
Yes,
Please,
please.
can you come again?
I should come again. Okay, from where?
Where you got the 4x?
Okay, so remember, ordinarily, you would have written it this way, and I said that doesn't show maturity. However, if that is your comfort zone, deal with it that way. It's better to play it safe in maths always. So you know that you are going to write 2s squared, then into the whole of what you have here, then plus what 6x, okay, times the whole of what you have here. That will be how we'd have written it. GHS, is that not it?
Yes, please.
Then you come and multiply this, then all the terms here. This and all the terms, then you add. But I said this is not necessary. You can do that always mentally. So it will be this term multiplying all the terms here, just as maybe if you had written it, you would have done so. So then when you are done, you come and take this term and multiply. So you are going to get 2s squared times s squared. What would that give you?
2x exponent 4.
Exponent 4. Did I hear exponent 2? Did someone say exponent 2? Okay, please take note, it's exponent 4. You know, in indices, anytime you are multiplying, okay, anything with the same base, okay, you keep your common base, then you add the exponent. So that will give us the 4. Is that clear?
Yes.
Okay, so you do same. 2s squared times 4x, and that will give us what? Plus 8s cubed. Am I right?
Mr.
Yes.
Hackman,
Mr.
Yes.
Hackman,
please multiply. Okay.
You can talk.
Okay, you are multiplying 2x squared by x squared, and you wrote 4 raised to the power 4.
So it's supposed to be
2x raised to the power 4.
very good. Okay, so it means you are well alive. Okay, you people are not sleeping. Your eyes are wide open. Okay, so obviously it will be 2x to the power 4 because 2 is the only numerical coefficient here. The other one is 1. So this shouldn't be 4. Take notes. All right. Okay, so at this point, this must go. Okay, and it will change to 2. So it means you are following. So that was why, okay, Rebecca said, was it Rebecca who said she doesn't understand?
No, please.
No,
Okay,
please. It
okay,
was
who
me.
was, it was you, Sayram.
Yes, please.
Okay, so it means indirectly, because Sayram was the only one who complained, it means she was the one, okay, who understood. Okay, so now let's move on. Okay, maybe you decided not to say it, but next time say it. That will give me the convention that you are indeed following. So 2s squared multiplying this will give you, okay, 6s squared. Am I right?
Yes, please.
Take note of what I will write. Oh, okay, all right. Okay, so at the point, then we are done with, okay, this multiplying the, what do you call it, all the terms here. Now you come to 6x, okay, to multiply all the terms here. So 6x times s squared will give us what?
6x cubed.
Very good. Okay, 6x, okay, times 4x will give us 10x squared. Am I right?
No, please.
Okay, what would that be?
24x.
Okay, the 6 will multiply the 4, it will not add. So that will give you plus 24x squared. I hope you are following. Then 6x times 3 will give you plus 18x. All correct.
Yes, please.
Okay, so at
Yes.
this point, after expansion, we are going to combine like terms and rearrange if necessary. Okay, so we'll do that together and, okay, bring in our conclusion. So on that note, let me clear this to create room, okay, more room for, okay, my conclusion. So this should go. So take note of that. Okay, so now what do we have? Okay, so I will write therefore, okay, 2 f of x times h of s, what I was given, will be equal to, the highest power will be s to the power 4, and it's positive, no other term. So 2s to the power 4. Then I go to, okay, my x is looking very ugly. So let me clear it and write it well. Okay, then you come to the s cube. You have 2 of them. One, which is here, okay, 8s cube plus 6s cube. And what would that give us? Plus what? 14s.
14x.
Okay, 14s cube. Okay, then we go to the square term, 6s squared. That's the only square term. Do you agree?
No,
No,
please.
please.
Okay, do you have any other square term?
24.
24 what?
Yes,
S squared. I wrote x. Nobody cautioned me. So from what I have here, this is the only S squared term. So you cannot tell me that this is an S squared term. No, this is S term, unless we go and do the right thing. Is that clear? So immediately
yes,
take note.
please.
The reason why I'm playing tricks with you here, immediately one of the terms is wrong, everything will be wrong. So you have to be very, very careful. You will not be dealing with the same expression. Immediately one of the terms, okay, is wrong. Take notes. All right. So every step on the way, make sure you write the right term. So it means now I can combine, and that will give me what? 30s squared. Is that clear?
Yes, please.
Okay. Now you know you are supposed to come down. Our next term is supposed to be S term, and there is only one S term. Is that not it?
Yes,
And
please.
when you are coming down, please take notes. You know I've exhausted this line. Okay, so I need to come down. When you are coming down, don't come and write it here. Still continue. Okay, close to the margin. So you come and write plus, okay, 18, okay, x. Take note of that. That's the more reason why you are encouraged, okay, to introduce each step with an equal to, so that if there is a spillover, we can easily determine that that is a spillover. But assuming, this is just by the way, assuming maybe I don't write equal to, which some of you do, okay, I've been given an expression, okay, I am writing whatever that I'm supposed to write. I don't write equal to. I come and write, maybe the expression gave me 2x, okay, I expanded plus 5x cubed, okay, minus 6x, I'm just assuming, plus 1 minus 8x plus 6. I've exhausted the line. Then I will come and write maybe, okay, plus 8 plus whatever. Okay, and you come down 2s squared, whatever. You can see because you didn't write equal to, it becomes everything my business to see or check which one is the continuation of which one. And you'll be frustrating the person who is marking. However, if I put equal to here, okay, my next step equal to here, automatically I will know that this is a spillover because there is no equal to there. You get the point?
Yes, please.
So you make the work very easy for us. So as you make us smile, we are also tempted to make you smile. That's the law of nature. For every action, there is equal and opposite reaction. Okay, so take notes. That's the more reason why I will encourage you, each step on the way, use your equal to distinguish, okay, between them. Take note of that. So that will be it for that of the C. Remember, I told you the D, you will do it and what? And submit it for me to see. So I am waiting for the solution to D. Okay, so I have the solution for the D here. Let me walk you through. Okay, so Janice has now seen the light. I thank God. Okay, so here you know minus 3 h, so you extract what you have there. So this is a step, that's why you write equal to. You cannot write equal to anywhere. Okay, so equal to your first step. 3 minus 3, you substitute your h of x, you substitute your g of x. Remember, anytime you substitute, you have to put it in brackets. Very critical. Then remember the advice. How many factors can you see here? Hello, how many factors can you see there? Yeah.
1, 2, 3.
Hey, how many factors? You've not said anything. No. I only heard you counting, but you haven't said anything. I don't know where you ended with your count. It will be 3. This constant minus 3. This, okay, trinomial factor and this binomial factor. So I told you, anytime you have more than 2 factors, okay, as a guide, this is what you are supposed to do. Multiply the factors with the least number of terms first. So this is a monomial factor, 1 term factor, binomial 2 term, 3 terms. So these 2 will be the least term factors. So you multiply these 2 first. It doesn't really matter though. You can multiply this and all that and come and distribute. Deal with it your usual, only that is convenient and more matured for you to deal with it that way. So you are going to multiply the minus 3 and this. So take note. So there is no plus here. This is multiplying. So minus 3 multiplying this will give you minus 3s squared. Then what? Plus what? 3. But remember, I told you that in every algebraic expression, okay, if whatever you are going to write is negative, meanwhile, the next or maybe the other terms will be positive, shove it and write the other one first. So here, that's what I did. I realized that this multiplying that will give me negative. However, this multiplying this will give me positive. So I'll write the positive first, followed by the negative. That was the only thing that, okay, Rebecca didn't. But if you write the negative, that's not your conclusion. Okay, it's your conclusion that we said avoid, okay, starting with a negative term. If there is a positive term, at least one positive term. But because this is not your conclusion, it is allowed to write minus 3s squared, then plus 3 is allowed. Is my point well made?
Yes, please.
So now you've taken the question to your comfort zone. 2 factors multiplying. So each term here multiplying all the terms here. Okay, or each term here multiplying all the terms here. So I did it this way. So it will be this multiplying these 2 terms. It will give me 3s squared, okay, minus 3s to the power 4. This multiplying these 2 terms will give me plus 12s minus 12s cubed. This multiplying these 2 terms will give me 9 minus 9s squared. So at this point, I combine like terms and arrange. But remember, ordinarily, we are supposed to arrange in decreasing powers of what? Of x. So the highest power here is 4. So we should start with, or ordinarily, we should have started with what? Okay, s to the power 4. But here is the case that is negative, and we can see positive terms there. So I cannot start with this unless otherwise stated. Okay, so I move on to my next term. It's supposed to be s cubed term. S cubed term is also negative. I have to shelve that one as well. Okay, so the s squared, s cubed shelved. Now let me move on to my x squared. S squared, I will combine this and this, which will also give me negative. So that also will be shelved. Okay, then so it means you can choose to write them and later rearrange in your conclusion is allowed. But I want to combine the two. Okay, the combination and the rearrangement and the conclusion, I will do it together. So I'm going to get only the 12x. Okay, that will be positive. So I'll write that one first, followed by the 3s to the power 4 that I shelved, followed by the minus 12s cubed that I shelved. Then now the addition of 3s squared and the minus 9s squared, which gave me minus 6x squared. That prompted me to shelve. I will come and write it. Then plus what? The constant 9. And that will be it for your solution. Okay, Rebecca, as for you, I think you did exactly what was expected of you. So let me ask I think along the line too, I realized that Janice did the right thing, but for her conclusion, she would have gotten everything right. But even in your conclusion, if you start with the negative, okay, we won't penalize you that much. Only that show your maturity, that's all. Okay, avoid doing that. So I guess we are all fine.
Yes, please.
Great. So if that is the case, then this becomes your class assignment. You are doing this one and you are submitting by 8 o'clock. Take notes. I will capture it and put it on the platform though. So you are doing it and submitting by 8 o'clock. Take notes. Okay, of that. Okay, so on this note, thank you very much for making the class a success. Your contribution, okay, and what have you. God bless us all.